Welcome to another document database community meetup. Today we have two great guests, and we are going to talk about JSON performance in both PostgreSQL and MongoDB. Please welcome Umair Shahid and Semab Tariq. And I guess let's start. The stage is yours.
Okay, great. Thank you, Alexei, and thank you, the document database community for the opportunity. JSON has been a topic of interest for me personally for a long time. Unstructured data and handling unstructured data within a relational database. It had been intriguing since the very first time it was introduced a long time ago, and I just found it interesting that we should compare how the two most popular databases for ingesting unstructured data perform against each other when we run very similar benchmarks on them. So that's the topic of today. We're looking at JSON performance between Postgres and Mongo. I must admit to being at least a little biased because Postgres has been my bread and butter for more than 20 years, but more about that, well, actually, let me just move on to the next slide to tell you about it. So a little bit about me. The name is Umair Shahid. I have been with the Postgres community for more than 20 years. I'm the founder of Stormatics, and we provide professional services for Postgres globally. The mission is to help businesses scale Postgres reliably for their critical data. I live in Islamabad, Pakistan, with my wife and two kids and my mother. My son is 17 years old and my daughter is 14 years old. The terrible teens. If anybody ever tells you that your toddler is, the worst that it's going to get, they're lying. Teens definitely are the worst. Having said that, over the course of these 20 odd years that I have been with Postgres, I've seen a very interesting journey. When I started working with Postgres, people used to use the database because it was the cheaper option. People only used it because they didn't want to spend a whole lot of money. Today, when I talk to folks about why they're using Postgres, more often than not, the answer that I get is it's because Postgres is better. So it's been a very interesting journey over the course of the past 20 years where Postgres has grown and risen and matured to a point where it's just a better database to use. We are talking relational, of course, but that's the transition that we have seen. This is a 5-year trend chart. I've used data from DB engines to pick up the 5 most popular databases in the world. And I've crossed that data with the annual survey that Stack Overflow conducts with the developers. Essentially, they ask a few different questions of their developers, and some of those questions relate to what technology they love and admire the most. And over the course of these 5 years, MySQL started off at the top. So in 2019, MySQL was the most popular database, followed by Postgres, and then SQL Server, then Mongo, and then Oracle. In these 5 years, we've seen it's only Postgres that has actually risen. Every other database has fallen in popularity, with Mongo being another exception, which rose in popularity between 2019 and 2022. And between 2022 and 2023, there was a slight drop. And it would be interesting to know why that slight drop happened. But this is the popularity over the course of 5 years as per Stack Overflow and DB engines. A little bit about MongoDB. It was first released in February of 2009. It's a document-oriented database that uses the BSON data type, which is binary JSON. It's designed to handle large amounts of unstructured data. It can scale really well horizontally. It comes built in with sharding technology. Its licensing is SSPL, which OSI rates as source available, not truly open source. There's a slight difference. The claim to fame is the ease of usage with application development. Application developers have very rapidly evolving needs, and MongoDB has been able to keep up with those needs. It broke through the bounds of traditional SQL, which is what made it so popular with application developers who could then deploy their application on a database without worrying too much about the mapping between objects within their programming and the schema structure in the database. So Mongo has been very, very popular with application developers that way. Now, when we talk about unstructured data, even though Mongo was released in February of 2009, we did see some unstructured data in Postgres as early as in 2006. So more than 2 years before Mongo was first released, we used to have the HStore data type in Postgres, which essentially is a key value pair that you can use without the need to define a schema. But it really broke grounds with the JSON data type, which was introduced in Postgres 9.2, which was released in September of 2012. And then JSON-B, which is the binary format of JSON, it was introduced in Postgres 9.4, which was released in 2014. It includes the native data type, and it has the binary representation, indexing. It has native operators and functions and conversions built into the relational database. So essentially, you can use both relational and unstructured data within the same technology. So that's a bit of an interesting aspect of Postgres. A bit more about JSON, about how what JSON is, how it's used. So on the right over here, you will see an example of a typical JSON object. The full text is JavaScript object notation. That's what JSON is short for. It's an interchangeable data format, which means that you can move between technologies, between platforms, between languages, and the same format is acceptable, is readable, is writable by those different platforms and technologies. And as you can see in the example, not only is it easy for machines to read and parse, it's easy for humans to read as well. It's very close to plain English, and you can make out, what it means. So essentially, in this example, there's a name, which is John Doe. There's an age, which is 16. So, we can say that this structure is probably about a John Doe who is 16-year-old. He's a student and takes maths, history, and English as courses. Lives in example city, whose zip code is 12345. So very human readable format, and the structure is in key value pairs. Moving on. Some reasons why JSON is so popular. One, of course, is that it's readable by both humans and machines because it's text-based. As we saw in the previous slide, the clear key value pairing is easy to read, and with the very clearly defined syntax, machines it's easy for machines to parse and to generate as well. The programming behind it and the logic behind it isn't too hard to implement. Very lightweight, independent of language. So, a Python program could be talking to Ansible to deploy, something on in a mass production environment, and they can easily talk to each other in JSON. You could be talking from an on-premise system to your system in the cloud, using JSON, and each would be able to decipher and understand what the other is saying. Very widely supported by platforms, frameworks, and APIs, and many programming languages have built-in support for this data structure. It supports many different data types as well, including strings, numbers, arrays, objects, booleans. and the usage is standardized across platforms, which is also what contributes to its popularity. Moving on, talking about the JSON standard, there are two documents, one by the name of RFC 8259, which was written by the Internet Engineering Task Force, and the other document by the name of ECMA 404, which was written by the European Computer Manufacturers Association. Both have pretty much the same title and can be used interchangeably because they both define the exact same standard. And what that standard does, it defines the data types, the syntax rules, enforces Unicode encoding, talks about how to parse and serialize, so move between JSON and data structure and back, and also defines how to handle errors within JSON. Some of a deeper dive of the syntax rules. Again, going back to the same example that I had in a couple of slides ago, it has objects which are enclosed by curly braces. So if you can see my mouse pointer, you'll see that the main object starts here, that's the curly brace, and it ends here, which is the ending brace. And there's an embedded object of address in here as well, which also starts with the curly brace and ends the same way. Each of these keys are enclosed in double quotes. So name, age is student, courses, address, city, and zip code, these are keys. And the values of these keys are separated using a column, which you can see over here in each of these lines. It supports arrays, which are enclosed in square brackets, which you can see over here, math, history, English. And each of the elements of the JSON structure is separated by a comma. The strings are enclosed in double quotes, as you can see with an example city and 1, 2, 3, 4, 5 over here. And you can also have numbers and Booleans. So you have a number over here that says age 16, and is student is true, which is a Boolean over here. The commas are used to separate the different objects within the JSON data. And white space, it's good to have in order to make it nicely formatted and more human readable, but machines don't really need the white space. So if you just get rid of all of the white space that you see over here, machines will still be able to read and parse the JSON data. Now, on to the real meat of the presentation. That's Mongo versus Postgres. I will let Semab, who my colleague, who has actually run the benchmarks, first introduce himself and then define the exact benchmark that he ran. So over to you, Semab.
Thank you, Umair. Hello, everyone. So this is Semab Tariq. I have done my bachelor's in computer sciences from Capital University of Science and Technology here in Islamabad, Pakistan. And I have started my professional Postgres journey from second quadrant back in 2018. Actually, Umair was the one who hired me there. And where so at second quadrant, I have mostly worked on automation related tasks, written a couple of blog series on machine learning with Tuda. So Tuda was the tool designed by second quadrant, and worked with different customers to provide them on demand builds and packages. In 2020, in earlier of 2020, second quadrant was acquired by EDB, and then I moved to Enterprise DB, where I continued working on packaging side, DevOps. I was heavily involved in DevOps side and worked with some migration tools as well, where we have integrated Oracle Sybase and Postgres containers with migration tools created by EDB. So now recently joined Stormatics as a database developer, adding a new chapter to my career. So yeah, this was a brief intro of myself. Can we please go to the next slide?
Okay, there you go.
Yeah, thank you. So let me first talk about environment that was configured and used to run this benchmark. We have divided this into 4 parts. Starting from hardware, we have actually used AWS EC2 instance. That I used was T3.xl that has 4 cores of CPU plus 16 GBs of RAM and 500 GBs of EBS storage. The OS used was Ubuntu 22.04, and on top of that, both of the databases, Postgres and MongoDB, was running in parallel. And finally, the benchmark tool that we have used to actually perform these tests was originally designed by Enterprise DB, and the name is PG_NoSQL benchmark. Yeah, next slide, please. To install the databases, we have actually used official packages provided by Postgres and MongoDB communities from apt package manager, and we have kept all the default behaviors of databases, and no parameters were tuned to actually perform this benchmark. Next slide, please. Okay, so let's now talk about a benchmarking tool that we have used. So first of all, as mentioned earlier, it was designed by Enterprise DB back in 2014. Yes, we know this is a pretty old tool. This is why we have to make a couple of changes to make it work. For example, the code wasn't compatible with the latest version of databases, so we have to actually modify a few code here, and a few functions were deprecated in the latest versions of databases. So we actually need to replace the deprecated version with the latest available versions, and we have to rewrite some select queries so that just to ensure that these select queries can perform with proper indexes in Postgres. So next slide, please. Okay. So this utility actually create a database, actually create a table that name is JSON_table, and that table only contain one column that is and its name is data, and that data type of this column is actual JSON-B type. Same goes for MongoDB as well. In MongoDB, we actually have a collection named JSON_table. So the data that we have used is generated at runtime. So that data actually is you can say catalog or inventory of electronic products for a brand. So each row or each row in Postgres and each document in MongoDB can contain a couple of keys that mentioned below. So name would contain the name of the product, brand would contain the brand name of that product, type would be if it is a mobile device, a TV, etc., and price of that item. If that item contain warranty, then warranty years. So availability of that product. This is a Boolean. It can be either true or false, and some information about the product in form of string. So here name, brand, type, all are these in the form of string, where price, warranty year are float, and available is Boolean, and description is of course a string. Can we go to next slide, please? Okay. So this is just a sample of data. So this is actually a one row representing the data inside Postgres or MongoDB, where we can see the name of the product, type, brand name, product price, availability of that product, and the product description, where description is just a dummy data that is cut short because the total length of this paragraph is, I think, around 350 words. So then finally warranty years. Next slide, please. Okay. So finally, we have select. This is just a simple example of select query that where we have used B tree and gin indexes in Postgres, and a single field index in MongoDB. So this query actually retrieve the data from the row where brand name is Acme. So just to give you an idea, if there is a 0.5 million rows in database, that query would return around 45,000 rows from once you run this query. Next slide, please.
Sorry, we have a question, so might be the best time to actually answer that while we are still there. Could we go on the previous slide? So
Yeah.
So the question is how we store data in MongoDB and PostgreSQL. My understanding that in MongoDB we just store a document in collection, and in PostgreSQL what we do, we store the whole JSON-B object in a single column. So effectively our rows have each row has only one column called data in that example, right?
For the purpose of this particular benchmark, we only have a single column in the table, which is JSON. So we try to bring it as close to the Mongo functionality as possible. But you're right, Mongo is built ground up to store unstructured data in the document format. Postgres is not. Postgres is a relational database, and the JSON functionality is an add-on functionality on top of the relational structure, right? So although the way the two databases store this document cannot be apples to apples, but the load that you put on both of these databases to try and compare the performance can be apples to apples, which is what we're trying to achieve over here. So the actual storage is different, which is why these are two different technologies. And the whole point of this benchmark is to try and determine whether it's worth having these two different technologies, whether it's worth going to a non-relational structure, and what is it that we gain or lose when we go to the non-relational structure. Does that help?
Yeah, I hope so. Thank you. Yeah. Let's continue.
Okay. So, Semab, I actually have a couple of questions for you. So tell me a little bit more about this. You said that 45,000 rows are returned. Maybe dive a little bit more as to why that number is significant. Are you saying that these are the queries that this is the number that you expect? Is it going to be different for different loads that you have put on the database? How is this number significant?
So actually, we have performed a different set of benchmarks like 0.2 million, 0.5 million, 1 million, 1.5 million, and so on. So this exact number, 45,000 K rows, can vary from benchmark to benchmark. That can be increased in if we perform exact query in 1 million rows. If we have 1 million rows inside the database, and we actually perform this query in 1 million rows, so that number can be changed in maybe increased to 60 or 70,000 as well.
So would it be fair to assume that if for 500,000, the number of rows with the brand Acme is 45,455, For 1 million, it would be twice that number. So that adds up to what? 90,910. Would it be fair to assume that it would be linearly increasing like that?
Um, I haven't checked on 1 million rows. What is the exact number? But I think we can assume really that this can be double up.
Okay. Okay. And in terms of, actually running the benchmark, because there is a strong probability of tuning the database for specific workloads to make it perform better, how do you ensure when you run your benchmark, how do you ensure that the databases that you're testing do not get an edge because of that extra tuning?
We have run all the tests on default settings. We haven't performed any parameter tuning by ourselves. All the parameters and settings are default one.
Okay. Okay. So essentially, you just take Mongo and take Postgres as they come out of the box, and you run the benchmark on them without changing anything.
Correct. We just install on our system. We just install both of the databases on the system, and without performing any parameter tuning or updating any parameters, we just trigger the benchmarks.
Okay. Okay. Great. Great. Well, thanks for the clarification. Of course, we have worked on this before, but I just wanted to make sure that our audience also understand the clarification for these aspects. And for everybody's benefit, this is the very first time Semab is speaking in front of an audience. We were working on this just a little while back as well, and I said that, you'll do a great job. I'm sure you will, and you did. Thank you so much, Semab, for walking us through this. I think this is wonderful work. I know that you've been working for 2 weeks now, more than 2 weeks now on these benchmarks. So I really appreciate the effort.
Yeah. Thank you, man. Thank you.
Yeah.
Thank you for encouraging words.
Sure. Alexi, I see that somebody has raised their hand. Do we take the questions with the raised hand, or?
Yeah, I do have a question here. So my name is Naman. I'm a Flutter developer. I'm from Lahore. So I just wanted to ask, can you give a brief insight about what are the different possible document structures that we have in non-relational, NoSQL databases? Because I had a little much confusion about that. If we can talk very briefly about that, that would be very helpful to me.
So that actually goes beyond the scope of this particular session, beyond the scope of this particular webinar, because we are focused on JSON, which is the most popular structure in unstructured data. But very briefly speaking, we could have data like storing images and videos. We could have data of geospatial information, and we could have graph data. And more popularly nowadays, we could have vector data, which is conducive to AI and ML workloads. So there are different forms of unstructured data that are out there. JSON just happens to be the most popular one of them. I hope that helps. Okay. So the results that we see, I know that Semab took great pains to try and ensure that it's an apples to apples comparison, and that despite my personal bias, he tried to make sure that the benchmarks didn't have a bias in there. So let's see what the graphs look like. So the first graph over here is for bulk loading data. So, this is not just, your routine insertions and updations that an application does. This is more of mimicking a behavior of loading data for the first time when you're trying to kick things off, bulk loading. The green line is Mongo. The blue line is Postgres. And the graph talked about in increments of 0.25 million, starting from 0.25, going on till 1.75 million rows, bulk inserted, bulk loaded. And we see that both Mongo and Postgres grow linearly in time as the number of rows increase. So, this is pretty, expected that the more rows you insert, the more time it's going to take. And both Postgres and Mongo behave in exactly that same way. When you insert more rows, they take more time to ingest that data. Now, remember, this is unstructured data. This is JSON data being bulk loaded into the default configuration of Mongo and into the default configuration of Postgres with the exact, apples to apples configuration or the structure within the database. And as we can see that the difference is small enough that I wouldn't say that there's a clear winner between the two databases. You can see, however, that Postgres performs marginally better than Mongo at ingesting large amounts of data being loaded into it in bulk. So here's one trend line that came out of the efforts of Semab's benchmarking. Another aspect that we tested was single inserts. This was trying to mimic behavior of applications as they ingest and insert data in production. So in production, when an application is ongoing, it typically does not do a bulk load. It's very rare that happens. It's typically a single or a bunch of inserts that go in every now and then, along with updates. And here we saw something very surprising, which was that Postgres actually performed significantly better than Mongo in ingesting that kind of data and situation. And one thing that I'd like to point out for this particular graph, is that this is in logarithmic scale. So this is, the previous one was linear, but this is logarithmic, which means that the actual difference is higher because this graph is trying to compress the data into something that you can see on one screen. The actual difference is greater than what you see in the lines being denoted over here. So this is something that we found surprising, that Postgres was significantly faster at ingesting single inserts, compared to Mongo. A third test was about the size on disk that the data occupies once it has been ingested. So the previous two slides talked about the rate of ingestion of data. So we had ingestion at bulk rates and ingestion at single inserts. This is about what the data looks like once it has been ingested and has been stored in the database. Now here what we see is that the growth of data on disk is linear with Postgres, but Mongo actually performs much better than Postgres over here. So by default, when data is inserted into Postgres, it's only compressed if it goes beyond the bounds of the single page size of 8K. But with Mongo, there are specific compression algorithms that help reduce the size on disk for data with Mongo. And that shows in this graph over here. So Mongo was performing really well in terms of the amount of space it takes on disk with the data that is being that's ingested. The conclusion that we came to when we talk about write to the database and writing JSON data into Mongo and writing JSON data into Postgres, the conclusion that we came to was that Postgres is more efficient at ingesting the data, whereas Mongo seems to be better at storing the data because of its compression algorithms. Now, most of our experiments, most of our benchmarking was oriented towards the ingestion and writing of data, but we did also want to explore a little bit about the reads, the select performance of the two databases. So, Semab ventured in a little bit. He did talk about the select queries a little while back in one of his slides. And just to revise back, to revise what exactly is being selected. The entire data JSON object is being selected from the table where the brand name is Acme. And just as a revision, for a reference point, if 500,000 rows have been inserted in the table, there are about 45,000 rows that are going to be returned in the result set of this select query. I see a hand has gone up again.
I'm sorry. I'm sure that I hope that you're not getting disturbed by my questions. So
it's okay. Go ahead.
I just wanted to ask that is there any specific JSON schema that MongoDB enforces?
So Mongo is a schema-less database, which means that there is no schema defined, and JSON can take on any format. That's essentially the spirit behind JSON data anyways, that it should be able to take on any format that you want to, and you should be able to change the schema or the format of the JSON data on the fly if you want to.
Thank you so much.
Yeah.
So in more recent versions of MongoDB, they actually introduced optional schema. So you can specify JSON schema for your JSON collections. And then if you know the data types, MongoDB could enforce it. I don't think that many people use it in practice.
Yeah, I guess, and maybe, Alexei, I can ask you this question. Why do you think people don't use it in practice?
So MongoDB has a lot of history, and they were very successful in early days. And it seems like the feature set that is actually being used by most users is quite old. So most people don't use transactions, they don't use schemas, etc., etc. But I guess the like top 1% of most important customers, most paying customers use all that. But as we talk with community members of FairyDB users, most of them don't use those advanced features.
Yeah, that's what I would have guessed. Thank you for pitching in, Alexei. So yeah, that's what I would have guessed. People go to Mongo for schema-less, for unstructured data. If it is structured and if it is schema, it might be a relational database that people opt for instead of Mongo. But yeah, thanks for pitching in. I see another hand raised. It's Hasib Ijaz.
Yes, thank you. I mean, I just had a question that we are approaching the benchmark in the way that the data at hand is not completely unstructured but semi-structured, meaning that some part of it is relational and some part of it is unstructured, which is JSON. So we basically try to fit that data in a row in such a way that the structured part is being stored in the individual designated columns or fields, and the unstructured part is being saved in that specific field. So the so when we have semi-structured data in hand, we will try to go about this benchmark. Is that correct? Are we approaching it that way?
So if I understand your question, Hasib, what you're saying is that if we have a mix of data that is relational as well as unstructured, how
Yes.
would this benchmark apply to that data?
No, I mean, we won't be able to achieve this benchmark if the data is wholly, if the data as a whole is unstructured data. Since we can't store the unstructured data in PostgreSQL, we would have to store in a single field. So if we have the data in semi-structured form, that is, some of the data is relational and some is not relational. So it would be better to go about this approach. Otherwise, it would be just storing a relational record and putting all the unstructured data in that field, which is basically a relational record for PostgreSQL, but it is a single field. That's what I understand. Have I explained it a bit?
Right. So I think the purpose of this exercise is to compare specifically JSON performance between the two databases. So it's important to understand what the scope is that we're defining. right? So if we're defining the scope as JSON, then we use the JSON in exactly the same way across the two databases to see how they perform and how the performance compares with each other. So that's the purpose of this entire exercise. If we were to compare performance of, let's say, a blob across the different databases, we would take a benchmark that considers blobs only. Or if we were going to do a mix and match, it would have been a different benchmark. But that goes beyond the scope of this particular exercise, which was focused only on JSON.
Okay. Thank you
So
very
this
much.
is so this is why our table only contain one column, and that is a type of JSON B.
Right. So JSON
so-
B in Postgres and
Clarifying.
BSON in Mongo. Yeah.
Yeah, so when you inserted this data, did you create indexes in advance or after the fact?
So I think
Um,
Mongo, but actually, Semab, you go ahead and answer that. You were the one who did this. Yeah.
So indexes were created right before performing the select operations. So when we bulk load the data, there was no indexes.
Okay, and someone asked a question, which is basically maybe not really a question, but maybe the difference between performance and insertion speed could be because MongoDB does some compression. So that would explain the much smaller data size, but also slightly higher, slightly lower insertion speed. Yeah.
So if we look at, sorry, I was going in the wrong direction. So the thing is, Mongo is compressing the data as it gets inserted, and it's compressing the data in the case of bulk load as well as single inserts, whereas the difference in performance is significant with single inserts. So maybe there is something going on behind the scenes with Mongo that is causing it to slow down, but the difference is so huge that whatever is happening behind the scenes is actually detrimental to the performance. So it just puts a question mark on what's going on. But yeah, you're right. It does give the advantage of the on-disk size of the data because that's significantly better than Postgres. Okay. So
Okay, you did not use, okay, how the benchmark works under the hood? Does it use transactions for both PostgreSQL and MongoDB?
I'm sorry, I didn't quite catch your query.
Does the benchmark use transactions?
Semab, you want to answer that?
No. No transactions was used. So single queries were used to actually insert the data and retrieve the data.
Okay, and for a single insert, you just send one value in one insert command, and for other graph, I assume you insert in batches.
So for batches, we use built-in Postgres module, that copy module, and single inserts, we use insert queries only.
Okay. Let's see. Yeah, so people asking for reference resources, like, do you have all those benchmarks on GitHub somewhere?
So we did share a few links. So there's a GitHub. The Stormatics GitHub has the forked benchmark, which is over here. So you can see the fork. It's github.com/Stormatics/PG_NoSQL_benchmark. So that's the forked code that you can find over here. These results, however, have not yet been published in GitHub. These results need some more refinement that I hope can result in a white paper fairly soon that we can share with the community once we have compiled them.
Yeah, so everyone who is interested could just watch your organization on GitHub. So either in that repository or on some repository next to it, you will publish results.
Yes,
Okay.
absolutely.
Awesome. People asking, was the column toasted?
So I think so. a column is toasted when it exceeds the size of a single page, and a single page size is 8K in Postgres. I don't think any of the values that got inserted were more than 8K. Semab, please correct me if I'm wrong over here. Please keep me honest.
Right.
So yeah, I think even with the with the descriptor, with the lorem ipsum kind of gibberish in there, it did not exceed 8K. So if I didn't go in looking, but I doubt that any of these data was toasted.
Okay.
Okay.
Did the file system use any compression?
The file system?
Yeah. I guess if it's Ubuntu by default, then file system compression wasn't enabled, but
Yeah. So Semab, you want to take that? I'm not aware of any file system compression that was used. I mean, we just took Ubuntu out of the box as it exists on EC2, right?
Maybe they are talking about that hard drive type that we have used or something.
So there might be encryption at the file system level with the OS.
No, there was no
Did
no encryption. There was no encryption. We just
sorry,
used.
compression. I meant compression.
No, I really don't think.
Yeah.
okay.
Okay.
Was PostgreSQL table locked or unlocked?
So it's the default. I think that the logging is pretty minimal when it's set as default. What comes out of the box with PostgreSQL.conf, that's what we used.
No. Sorry, I wasn't mean the logs of the PostgreSQL, but there is like an option to create unlocked table in the PostgreSQL. So benchmark, did it use unlocked table or regular table?
So by default, it is enabled, I think. So yes, it is enabled in Postgres.
Yeah. But by default, logging is enabled at a minimalistic level, and that's what was used.
Okay.
By the way, I do have a couple of slides to go. I'm not sure if people think that we're done.
Okay, yeah, let's continue.
So we did the results, and we came to the conclusion of ingestion of data, but we also wanted to try a little bit on the selects, and the select query that we were talking about, where we were expecting about 45,000 rows to be returned for 500,000 rows of data. Here's the graph that comes up. And the select performance is very interesting between the two databases. We see that Postgres performs well at lower rates of data, but as the data grows bigger, Postgres performance begins to drop. Now, again, this graph over here is at logarithmic scale, which means that it's magnified and kind of tries to portray exactly what's going on, which means that Mongo remains pretty consistent with the performance of selects, the way we are defined it, no matter how many rows are there, or no matter how big the data is in the table. But Postgres performance deteriorates over the course of increase in size of data. So this was pretty curious for us, looking at why there was a very sudden increase once we went beyond the 500,000 mark over there. So we went in and we looked at the various shapes and forms of the indexes in Postgres and how they're working with the same data, as the data set increases. So the blue line over here is the standard B-tree index. The yellow line is a parallel sequential scan, and the red line is a GIN index. Now, GIN indexes in Postgres are designed for document data types. They are designed to perform well with JSON styled data. And we see that for the most part, the GIN index does perform fairly well. But then after 1.25 million, it just goes a little crazy. And we're a little puzzled as to why this is happening, because that's not how GIN indexes are supposed to perform. They're supposed to perform definitely better than the parallel sequential scan, and hopefully better than the B3 index. But over here, we see that they actually are performing worse than even a sequential scan, which means that there's something wacky going on that needs some more investigation, which hopefully can be a topic of a subsequent talk, because for this we were focusing on ingestion, and the select performance leaves a few questions in our minds that we hope we can address at some point soon. So those are our next steps. And this actually, brings us to the end of the slide that we have. I wish I had, Semab, I had your QR code over here as well. But for our audience, please connect with me on LinkedIn. We have the QR code over here. For Alexei, happy to take any further questions that are coming up.
Yeah, there are some opinions about like what could be the explanation for that select speed, but I guess you just covered it. People are also saying that if you used unlocked tables and speed up maybe up to 3 times. But I would say that, yeah, on MongoDB side, you can also disable fsync and it will be much faster, but you want to save the data, right?
Yeah, I mean, one could argue that tuning a few parameters and playing around with a few knobs here and there can improve the performance, but that is going to be true for both databases. I mean, if I, as a Postgres expert, tune a few things with Postgres, then somebody from the Mongo side can come and say, well, here's how you can improve Mongo's performance as well, which is one of the main drivers of using both the databases right out of the box, the way they're presented, without any tuning whatsoever, right? So yeah, I mean, locked table, if a table is locked, and then you do whatever you want to do with, you disable an index, you lock the table, and then you dump data in there, the performance is going to improve. But then that beats the purpose. Then it's not an apples to apples comparison anymore.
Yeah. I was just wondering if that's default configuration for both PostgreSQL and MongoDB are way too conservative, because the default installation should be able to work on even like very unpowered hardware, and maybe defaults are very low, but also differently low for different packages. So I'm looking forward to see the result of benchmarks like for tune configuration.
Yeah. No, I agree with you, Alexei. I think that the Postgres parameters I know out of the box are not well tuned for modern hardware, but they are present to make sure that even in a very minimalistic hardware environment, Postgres can still perform. And I think that same holds true for Mongo. But again,
I think actually MongoDB default installation might be tuned much better than PostgreSQL. So some time ago, they even dropped completely support for all the processors that are not that old. So I think that MongoDB by default is tuned better than PostgreSQL.
So Mongo does have the advantage of being introduced to the world in 2009, which is almost 15 years. No, yeah, 15 years after Postgres was first introduced to the world, right? So in 15 years, a lot of things change. Mongo started off at a certain hardware level where Postgres has been around at a much baser level. But again, the intent was to be able to say, hey, we didn't touch anything. We just, ran the benchmarks the way the databases exist, so that there's no complaint from either side. I hope that at some point we can tune Postgres to its level best and Mongo to its level best, and then compare the performance and see how things turn out.
Okay, and we have a raised hand.
Hi, am I audible? Right?
Yes, Steve.
Yeah. So first of all, thanks a lot, Umair Shahid. I am a big fan. But I have 2 questions, right? So the first question is, so I want to ask the question question by question so that I don't lose the context. So the first question is, now we are trying to store the whole JSON in a single field, right? In a document database, we are trying to save a document. In that, in case of Postgres, we are trying to save that table record in a JSON field. So let's take a scenario. We have 1,000 tables and we want to store all the table data into the JSON in JSON format in Postgres. So storing all the tables with all their data in a single field for all the tables of the database for 1,000 tables, doesn't it look weird to you? I mean, you are still when you open when you list all the rows, you get a single field, and and for all the tables and for all the records a single field. Doesn't it look weird to you? The first question.
Okay, so Haseeb, the thing is that when it's a very unique outlier kind of a case, I would say that there will be always specialized tools available to address the case. So in case an organization has only document data, nothing else, and that is all they want to store, then maybe, yes, you do need a specialized document store. My point typically tends to be that Postgres is what I like to call a hyper-converged database, where you can store many different forms of data in the same database and still get the ACID guarantees and the relational compliance and the performance that Postgres offers. So you don't need to you don't absolutely need to have a separate database for your documents, one database for your graphs, one database for your vectors, and one database for your relational data. You can do all of that in a single place and not need the overhead of different technologies within the same organization. That's the entire pitch over here, right? But in case your specific use case is such that you only have document data and nothing else, then yes, absolutely go for a document database.
Right, I am very much convinced by the first answer, but I would like to conclude it. So what I have understood is I have understood is we aim to have one database to rule them all. I'm not considering the case when we have the whole data as unstructured data, but we can cover many streams in sense of the types. We can cover a lot of types with Postgres, and we don't be needing different technologies. This is one scenario. That is what I have understood. But there are other two scenarios when, for example, you have very few, 1 or 2, 3 tables, right? And you just want to store unstructured data for them. So in that case, you should not try to deploy or employ a different document-based technology. You can also use Postgres in that case too. Or for example, you have very few fields in few tables, or some of the tables. You can also use the same approach in that context. That's how I conclude that. Do you agree?
Sure, absolutely. And this will especially be true if you're used to Postgres, if you understand Postgres and you're comfortable with the technology. You would much rather continue using the technology that you're comfortable with rather than learning something brand new, right? That's true for any person in any organization. So if it's a limited outlying case, if it's a limited case where there's a little bit of unstructured data here and there, you would still rather use the technology that you're used to. If that technology is Postgres, then yes, you can do that in Postgres.
Sure. Thank you. And the second question is, so you used one of the parameter in the benchmark, which was storage, right? So nowadays, these days, storage is cheap, very cheap, right? And we don't care really about the storage. So I think what I think is storage is not the parameter. So storage is a parameter, but is not that important parameter as compared to the injection and the selection operations you performed. So what parameters would you put on the top when comparing apples to apples, or when we are in a specific scenario, like we are using like we are discussing ours? So I think, do you understand my question?
Yes, I do. And unfortunately, I may not be able to give you an absolute answer to that, Steve, because in my experience, as we work with different clients have different priorities. And one thing that is unimportant for one client may be very important for a different client, right? So it's possible that we come across a situation where a client says that, well, I just need to ingest data really, really fast. I don't care what the disk size is, and I don't care about reads at all. I don't read my data ever. I just need to ingest it really, really fast. And we could also come across a different client that says the exact opposite, and that is, um, I don't care if ingestion is very slow. I just need to be able to read it very fast, right? So it varies on a case-to-case basis, and depending on what the particular use case is, you pick and choose accordingly. So if if disk size is important to somebody, you plan accordingly, and if ingestion is important to somebody else, you plan accordingly.
So please let me conclude the answer. The answer to it is basically, it basically depends entirely on the needs. But what I want to say it. So for example, you have 20% of the scenario that are important 80% of the time, or are common, 80% of the time. So the CRUD operations are mostly important when you are not micromanaging the cost, right? So I am trying to get into that. So for also that scenario, would you agree to that it won't matter in that context for the 80% of the common scenarios when we are micromanaging the cost? Since we talk that and we agree that, I think that I assume that we agree that storage is cheap. So
So again,
want
see, I think that in your use case or in your experience, if storage does not matter, then more power to you. And yes, you can ignore the storage angle altogether. That's fine. But there are use cases out there where storage does matter, and we have to be mindful of that. I don't think that I can give you an 80-20 split. I don't think I can give you even a 60-40 split of what's important and what's not important, because it does really depend on the client. It does really depend on the use case and the people that that are using the database.
I have huge gratitude for you and the community that has organized the discussion. I enjoyed a lot. I learned a lot. Thank you very much, Umair, and all the guys. Thank you.
Appreciate you being here and appreciate your questions. Thank you.
Thank you. And I think that was the last question. We covered all of them.
Okay,
So, yeah,
that's great.
Yeah, thank you again for joining us, for delivering a great talk. And yeah, thanks everyone for joining, and stay tuned. We will have the next meetup scheduled pretty soon, I believe.
Yeah. Thank you, everyone. Thank you, Alexi, and thank you, the document database community, for hosting, right? And thank you, Semab, for running so many benchmarks.
Thank you. Thank you.
Take care, everyone. Bye.
Thank you very much. Just a minute. We have only one thing that you forgot about t-shirts.
Yeah, everyone forgot about that. So we have t-shirts for best questions or most active people, or whoever you want to give the gifts out.
Can you choose, select 3 people who
You want me to select right now?
Yes, please.
While we still remember the
that's...
questions.
Yeah, exactly. That's
We had a lot of them, but maybe I know some people who were most active people. So
one could be Umair.
Yeah, yeah.
Yeah.
No, I think one particular question that I think that I was impressed with was related to toast. I think that that was that came from somebody who really understood how Postgres internals work. And
Alex,
if the data is toasted,
Yeah.
it does make a difference in how it's stored. So that was a good question to ask.
Yeah, that's Alex Chen.
Alex Chan. Okay. One, then the second.
Semab, you want to pick one? Please help me with one.
I think that
Maybe you can go with that guy, Hasib. Because he was
No,
most active one as well.
but we have to pick a question, right? I mean, not a person. We have to pick a question. So
Well,
Yeah.
the questions do not wear t-shirts, so you can pick a person to.
No, but I think he was most active guy as well.
Yeah.
so. Could you repeat, please?
Um,
I need to
the name was Hasib.
Hasib, right?
Yeah.
Yeah.
Unfortunately, he just left, so.
No.
He did?
Okay, yeah, I see him. Yeah, okay, yeah.
and another question that was related to logged table. That was also an interesting question.
Yes, I agree.
Yeah.
Okay. Alex, say who was it?
It's what's Valer Agaev. I have it. Yeah. Yep. Yeah, I will send you details. Yeah.
Okay, good. Thank you very much.
Okay. So
all
we
the-
have 3 questions. We have
Yes.
3 winners.
Could you please?
Yes, we have them
Okay,
all.
great. Woo!
Yeah.
Yes.
Congratulations to the winners if you're still around.
Yeah.
Yes. We will contact them directly. So and explain how they can get the t-shirt.
Excellent.
Thank you very much. Thank you.
Thank you. Bye-bye.
Thank you, Maria.
Oh,
Thank you, Alexi. Thank you, everyone. Take care. Have a great day ahead. Bye.
you too. Bye-bye.
Bye.